this video, we will look at one more way to classify polygons. Polygons can be classified as either concave or convex. A polygon is convex if, for all points A and B in the polygon, the segment AB is contained entirely within the polygon. That's a formal definition, so let's unpack it. I have these two shapes here, and the idea is we want to pick any 2 points inside those shapes. It does not matter. Which 2 points? Any 2 points. And then we want to connect them with a line segment. If that line segment stays completely inside the shape, then the polygon is convex. But if I look at this one over here, if I pick this point here and this point down here, whenever I connect them, didn't do super great, but that's okay. I can see that it does leave the shape. That's concave. There is another way to think about convex polygons. A polygon is convex if each interior angle measures less than 180 degrees. That is often easier to check visually. I can see over here I have an angle right here that is greater than 180 degrees. And a polygon that is not convex is concave. Sometimes children say that a concave polygon is caved in along one side. That's actually a very helpful informal description. A concave polygon has at least one inward corner, or at least one interior angle greater than 180 degrees. Examples of convex polygons include our triangles, squares, rectangles, regular pentagons, and regular hexagons. Examples of concave polygons include our arrow-like shapes, certain quadrilaterals with one corner pushed inward, or pentagons with an inward dent. Now, let's ask an important question. Can a regular polygon be concave? I did add my regular pentagon and hexagon into my convex column, but is it possible for me to make a regular concave polygon? No, because a regular polygon is equiangular, which means all angles are equal. But a concave polygon has at least one interior angle greater than 180 degrees. If all of the angles were equal and one of them were greater than 180 degrees, then all of them would have to be greater than 180 degrees. And that would not form a regular polygon in the usual plain sense. Regular polygons are always convex. Now another important question. Is there any polygon that cannot be concave? And the answer is yes. A triangle cannot be concave. Why? Because the sum of the interior angles of a triangle is 180 degrees. A concave polygon would need at least one interior angle greater than 180 degrees. That's impossible in a triangle. So every triangle is going to be convex. This is a nice example of how definitions connect to earlier geometry facts. When students say that a shape is caved in, that can be a useful starting point, but we also want to help them connect that intuition to some formal ideas, like interior angles, line segments inside the figure, and precise definitions. That movement from informal language to formal geometry is one of the most important parts of elementary mathematics teaching, and you're building that understanding step by step. Great work.